Hello everyone, I hope everyone is doing well. I'm Gopika Subramanian. So before I begin, I would like to thank SeaGL GNU+Linux conference for inviting me to speak today. I'm very honored to be here and to have the opportunity to share my knowledge with you. So okay, a quick statement. Imagine a world where software is released quickly and securely without any security vulnerabilities. Right, so that is a promise of DevSecOps. So today I am going to be talking about DevSecOps, which is like a collaborative approach to security, which integrates security into the software development cycle, and about secure coding, that's a fix from root practice. Right. So a little bit about myself. In my role as a security engineer at PhonePe, I work to protect our users and their data from cybersecurity threats. Right, so PhonePe is basically an Indian digital payments and financial services company, which is headquartered in Bangalore in India. So I also work to educate our employees about security best practices. So outside of work, I enjoy competing in CTFs and spending time with my dogs. So I have 3 dogs, Crypto, Cookie and Proxy, the ones on the slides. And yeah, that's my Twitter handle if anyone wants to connect. So let's quickly go through the agenda. This agenda covers a wide range of topics related to web security, from basics to more advanced concepts. Right. So it is designed to be accessible for newbies, but it will be also very informative from more experienced audiences. So we will start with what is web security, why is web security important, common web security threats, why you should protect yourself from web security threats, Then we will move to DevSecOps. So what is DevSecOps? The benefits of it, how to implement DevSecOps for web applications or any sort of applications per se. Then we will split the fix from root into two segments. That will be attack and defense. So we will start with exploiting the web. That will be common web application vulnerabilities. Then how attackers exploit the web application vulnerabilities. We'll probably go through tools and techniques used by attackers. And then we will go to the fixing of the bugs. Right, so that will be how to identify and fix a web application vulnerability, and a bunch of secure coding practices and best practices. Right, so yeah, so we'll start with web architecture. Right, so what is web architecture? It's basically a set of principal technologies, right, and practices that guide to design and implement. It's like an implementation of web applications, right? It defines how web applications are organized, like how they should interact with each other, how they communicate with users. So one of the key principles of architecture is separation of concern. So this basically means that the web application should be divided into different components, each of which has a specific responsibility. So for example, a web application might have a component that is responsible for handling user requests. So that will be in the client side. Right, a component that is responsible for storing data, that will be in the data tier, and a component that is responsible for rendering the web pages, that will be the server. So another important principle of web architecture is scalability. Web applications should obviously be designed to handle a large number of users and requests without sacrificing on the performance or reliability of the application. So this can be achieved by using a variety of techniques such as load balancing, caching, and distributed system that we'll get in the next slides. Right, so there are multiple types of web architectures. There will be 3-tier web applications, microservice. So a microservice is basically where the this pattern divides the web applications into a set of small independent services. So each service has a single responsibility and can be deployed and scaled independently. So imagine you have a shopping cart application where there is an issue happening in the profile page. So you wouldn't have to exactly scale the whole application. Rather, you can just fix the issues in the profile and then scale that. Right, and there are multiple other architectures like serverless architecture. This is similar to microservice architecture, but it offloads the management of servers to the cloud provider. Right, so we'll go through a bunch of components of web architectures. So there are a bunch of components in web architecture. So DNS is starting one. So DNS is a critical part of the internet infrastructure. So it allows user to easily access websites and other resources by using domain names. So when you type google.com, it will be mapped to an IP address, right? So instead of having to remember IP addresses, DNS can be used. A particular domain name that's rememberable can be used. So it helps in improving the performance of the internet by caching domain names, lookups, and routing the traffic to, let's say, more efficient servers. Right, so yeah, next is load balancer. A load balancer is basically a device that distributes traffic across multiple servers. So this can be done for a variety of reasons, such as, let's say, you want to improve the performance or reliability or scalability. Load balancers are definitely an important component of many applications, as it can improve the performance. Like there wouldn't be a lot of delay. So yeah, next is database server. Right, database server is the self-explanatory thing, is a computer that basically stores and manages data. So databases are generally used to store a wide variety of data, such as customer information, or it could be product information, financial information. So database servers are typically optimized for, again, performance. So they often have multiple processors, a large amount of memory, and maybe a fast disk subsystems, right? So here next would be web application server. So that is a computer that runs web applications, as simple as that. Web applications would be generally programs that are accessed over the internet. So they're typically responsible for processing the requests, giving out the content, generating web pages, serving static contents. Just there could be CSS files, there'll be images, JavaScript files. So how does all these components work together? Load balancers, database servers, and web application servers, they typically work together in a 3-tier architecture. So the load balancer would be distributing traffic across the web application servers. The web app servers would then query the database server to retrieve the data and then generate web application pages, right? So next is caching service, right? So that's basically a system that stores data in a temporary location, not like the database server, but in a temporary location, so that it can be accessed quickly and efficiently, right? So caching services are often used to improve the performance of a web application by storing it frequently. So let's just say you go to facebook.com once, and the time that it takes to load it would be very less compared to the first time that you go hit the facebook.com's endpoint, right? That is where caching helps. So with the example, this can reduce the number of times that the application needs to access the database or any other data source. The next thing would be job queue. So job queue is a system that stores and processes jobs, right? It's like it takes care of the task that needs to be completed. So just let's say we have sending email or processing a payment or generating a report, downloading a report. It takes care of those tasks. And the next component would be data warehouse. That is like a central repository of data that is collected from a variety of sources. Data warehouses are generally used to store like old data for analysis and reporting, and it definitely helps in optimizing and performance as such. So cloud services, right? Cloud storage. So it's a service that allows you to store data on remote servers. So cloud storage services can be used to store a wide variety of data. Be it files, images, videos, or any sort of backups. So cloud services are typically used for better scalability. So this means that you can easily access, add or remove storages as needed, as simple as you have Google Drive, Amazon S3, Google Cloud storages, right? So even Microsoft Azure Blob Storage, even that is an example of that. And we have CDN, that's a content delivery network. It is a network of servers that are distributed around the world. So CDNs are used to deliver content to users with high performance and reliability. So when a user requests content from a website that uses a CDN, the CDN will deliver the content from the server that is closest to the user, right? So this can definitely reduce the latency of the content delivery and improve overall user experience, right? A bunch of examples would be Cloudflare or Amazon CloudFront, Google Cloud CDN. So these are a bunch of components of web architecture. So this is about OSI layers. OSI layers, or Open System Interconnection Model, is a model that describes low data, how data is communicated over a network, right? It divides communication process into 7 layers. Each layer has a specific responsibility. We have physical layer, data link layer, network layer. So these are the couple of layers, right, in the OSI. So how are we mapping this to the web server? So for us, we'll be having to discuss about the transport layer. The transport layer would be responsible for, let's say, breaking down the data into smaller chunks for ensuring that the data is delivered in a reliable manner to the destination device. So this would include protocols such as TCP, UDP, and the session layer, right? The session layer is responsible for establishing, managing, or even terminating sessions, right, between any set of two devices. This will have HTTP, FTP protocols, and we have presentation layer. This would be for formatting the data so that it can be understood by the receiving device, right? This has protocols such as MIME, TLS, And yeah, the topmost layer would be application layer. The application layer is responsible for providing services to the users, just web browsing, you can say email or file transfer. These have protocols such as HTTP, SMTP and FTP protocols. Alright, so now that we have a basic understanding of web fundamentals, let's get into a real world scenario. Right, so here is a statement. Rahul bought a year car insurance from ICICI Lombard at 20,000 rupees from PhonePe. Right, so here Rahul is the person, ICICI Lombard is the insurance company, and PhonePe is the medium through which he bought it. Right, so let's break each and every assumptions made by the system or any developer that's given this statement by the stakeholder. So Rahul pays rupees 20,000 for the insurance. Right, 20,000 in quotes because do we check if Rahul is exactly paying 20,000 or is he just paying 0 rupees and getting the insurance? And Rahul pays for ICICI Lombard car insurance, right? ICICI Lombard. Is Rahul getting the insurance from ICICI Lombard itself, or is he getting it from somewhere else? Rahul pays the insurance. So is it Rahul that's paying the insurance, or is it someone else who's paying the insurance, or is it me who's acting like Rahul and making Rahul pay the insurance for me? Right. So Rahul pays rupees 20,000 for 1 year car insurance. So is he exactly paying for 1 year, or is it for 2 years? Is it for 3 years? Rahul pays rupees 20,000 for a year of car insurance. Is it exactly car insurance, or is it term insurance? Is it health insurance? So these parameters are very crucial. Why are they in the double quotes, right? Just know that a slight modification in these can lead to a huge security issue. So that's the difference in a way a developer and a hacker thinks. For a developer, it's a set of values that the stakeholder gave. You just have to build an application and give it so that these values can be taken in and interpreted in the right way, right? So how a hacker thinks is these parameters are specific, are of a higher importance to them. What modification can be made in these particular parameters so that you can mess up with the system, right? So yeah, developers and hackers are both skilled at understanding and manipulating code, but they have different motivations and goals. Developers build software to solve a problem, and the problem statement being Rahul wanting a insurance from ICICI Lombard, right? So they build a software to solve problems and to provide value to users. Hackers are interested in exploring the boundaries of the technology and finding new ways to use it and exploit it. So a developer might be spending weeks carefully designing and implementing a new feature for web application. A hacker might spend a few hours trying to find a vulnerability in just simple of these parameters in the same web application that could be exploited to steal user data, to get more privileges, right? So yeah, now let's quickly go to the application layer, the bugs and the fixes, right? So here is a brief explanation that I'll be giving on schemes, right? Schemes, host names. It's like a URL decomposition. So we'll go through a quick explanation on what is a scheme, what is a host name, what is this query string, all these components of a URL, right? So the scheme is basically like a protocol used to access or any sort of resources, right? So common schemes would be HTTP, HTTPS, FTP, or SFTP. So a host name, the host name is like the domain name, as we discussed in the DNS component. It's like a domain name, or it could be an IP address of the server that hosts the resources, right? The path would be the location or the resources on the server, right? It could be /txt file, /profile, or anything. It's a path. So let's just say the path here would be like Google homepage, and then we have a slash and then the path. And the query string would be a string of data that is appended to the end of the URL. So the query string is usually used to pass data to the server. So such as search parameters or even login credentials. So let's just take an example: HTTPS www.google.com/search ? q equal to dogs. In this example, the scheme would be HTTPS, right? The host name would be www.google.com. The path would be /search, and the query string, that will be q equal to dogs. So the query string is parsed by the server when the request is received. So the server can then use the set of data in the query string to generate a dynamic response. It will be, let's say, if it's dogs, you get the response of everything that is relevant to dogs. If it's cats, you get the response of everything that is relevant to cats, right? So let's go to the next thing, that's same origin policy, right? This is basically to understand how the URL components are taken into consideration while sending a request, while getting a request to the domain too. So same origin policy and URL components, how is that linked? So let's get to what is same origin policy. So SOP only allows scripts on one origin to access resources on that same origin, right? So this means that a script or any set of information that's sent on one origin cannot access any sort of resources from another origin. Even if the origins are on the same server, the SOP doesn't allow that, right? So this is enforced by the web browser by checking if the origin of the script and the origin of the resources that the script is trying to access from, that's the same, right? So if two origins are different, the browser will block the request. So here are a few sets of URLs which the SOP would allow and decline to send requests from. So the set of bypasses a hacker can make are abundant. If you notice, these are very small, unnoticeable set of differences. Maybe a developer wouldn't be aware of such minor loopholes. So these are such small, unnoticeable events and differences that an attacker can use to manipulate any sort of web application, right? So what can be done about this? That's where we're getting into the topic, right? Alright, so what can be done about this? That'll be DevSecOps. DevSecOps, that'll be development, security and operations, is like a collaborative approach to security that integrates security into software development cycle, right? That's what we discussed. So it is needed to address the increasing complexity and even the sophistication of any sort of cyber threats that's coming up right now, and to ensure that security is built into the software from the start of the software development life cycle, right? So it's very powerful approach to security that can help any sort of organization to reduce the risk of security, decrease the number of vulnerabilities, improve the quality of the software, and even increase the speed and the agility of the software. So by implementing DevSecOps best practices, organizations can protect their customers and their data in a very efficient manner. So DevSecOps is basically based on a following set of principles. Security is everybody's responsibility. So everyone involved in the SDLC cycle, so be it the stakeholder, the business partner, the logical team that's implementing it, the SRE team, the development team, they have a role to play in building security into the software delivery process, right? And security should be automated. So every security task, just imagine, we all are humans. No machine is none of us is 100% efficient. We will be missing out on things. So automating things, security testings or any sort of remediation should be automated as much as possible to keep the SDLC cycle, right, to be moving very quickly. And the next thing would be security should be integrated into the CI/CD pipeline. So security checks should be integrated into the CI/CD pipeline itself, so that any sort of security issues that are identified needn't be pushed to the end, right? Needn't be pushed to the pen testers. It can be fixed at an early stage of development process. It'll be much convenient for the developers too. So here are a bunch of benefits of DevSecOps, I'd say. It'll be reducing the risk of security vulnerabilities. So DevSecOps helps to identify and fix vulnerabilities in an early stage in the cycle, right, before it is even released to the production. This can definitely help to reduce risk of costly and damaging security breaches. And there'll be improved software quality, which means that it'll be helping to improve the overall quality of the software. It'll it'll ensure that it is secure, and this can lead to improved customer satisfaction, again reduce the support costs that will be needed, and it can increase the speed and agility, and that mean that integrating security into the pipeline, right, and automating the tasks. This can help organizations release the software much more quickly and respond to any sort of marketing changes or any changes that is to be coming, that can be done in a very faster and a quicker way. And I think some of the best practices that for implementing DevSecOps that we even follow in our organization would be the shift security left. That'll be, it's basically about shifting security left in the SDLC cycle. This means that integrating security into all phases of SDLC, from planning and designing to development, testing, and development, and the development of after fixing the vulnerabilities. It needn't exactly be in the end of the process where it is just the pen testers doing a bunch of tests, sending it back to the developers. So, and another best practice that we can do would be automate security tasks. As I mentioned, automating it would be reducing a huge number of possibilities that a function could fail, a function could be missed. And we can even use DevSecOps platforms. We use a bunch of platforms that there are a bunch of platforms available that can help an organization implement DevSecOps best practices. We have a centralized view of what is happening in our organization by using these platforms, right? And so how do you implement this? So one thing would be assess your current state. Where are you? What kind of practice are you following? Or is it like a traditional practice where the developer builds things and it's given to the pen testers and it's rewarded back when the security issues are fixed? Just assess your current state, where the security is at, and how can DevSecOps be integrated. This will help you identify any sort of gaps to develop a plan for improvement, right? And the second thing would be establish a DevSecOps culture. It's needed to establish a culture of collaboration and security awareness. And again, awareness would be the best thing to be doing. We have a bunch of sessions we give to our developers, our reliability team, about how DevSecOps can help, how it can be helpful for the security team, for the whole organization as such. And probably implementing DevSecOps tools for any sort of procedures. There are multiple set of tools available. Choose the tools and processes that are like right for your organization. Start to implement them. So some examples of DevSecOps practices would be static code analysis. Static code analysis tools can scan code for potential security vulnerabilities. If you automate this, set it in the SDLC cycle, integrate it in the CI/CD pipeline, it will do the work automatically, right? And we have DAST, that will be dynamic application security testing. Those tools are test running applications for vulnerabilities. And we can also have security testing as code. Security testing can be automated using code itself, which makes it definitely easier to integrate everything into the CI/CD pipeline. And security orchestration, automation, and response. These tools can actually automate security incidents, responses, and remediations that can be done. Okay, so now we're going to the attack and patching. So we'll be going through, this is how we're gonna get to that. We will be going through a few web applications vulnerabilities. It's the vulnerabilities, how to exploit it, and then how to fix it, and why fixing from root is much more beneficial than traditional pen testing process. So penetration testing is a security assessment technique that involves simulating an attack on any computer system, network. This is usually done at the end of when an application is completely done, right? So they use a bunch of tools to identify and exploit security vulnerabilities. So the goal of this pen testing is to identify any vulnerabilities that can be exploited by attackers and to provide recommendations on how to mitigate those, right? So let's just say I get an application, I'm testing it, I find out vulnerabilities, and I give it back to the developers to fix it, right? So then finding bugs and then sending it back to the developers, they fix it and they test it again. Right, what is the fault in that? There's a lot of time that is wasted, and I'm pretty sure when one of my team developers called me, the thing that blocks my work from going live in the correct time. So what exactly can be done from the dev side for this not to happen? That would be DevSecOps, right? It's a more proactive manner of doing, say, like practicing security. And pen testing is typically performed at a specific point in the SDLC cycle, as I mentioned, in the very end. So this means that the vulnerabilities may not be identified and fixed until the software is completely developed, right? Completely shipped to the production part as such. So DevSecOps, on the other hand, is continuous. It's throughout the SDLC cycle, from the start to the end. Every set of developers or reliability team, everyone is involved in this. So the vulnerabilities can be identified at a very early stage and also fixed in an early stage too. This helps in reducing a lot of time for us. Okay, so let's start with the vulnerabilities. We'll start with excesses, right? Cross-site scripting is basically a type of web application vulnerability that allows an attacker to inject malicious code into a web page or any sort of web application. So this code can then be executed in the victim's browser, giving the attacker complete control over the victim's sessions. So excesses are usually a serious threat to web application security, and it's still there, obviously. And as you know, they can be used to steal sensitive data such as cookies or sessions or tokens and even credit card numbers. So they can also be used to redirect users to malicious websites or take complete control over a user's account. So I'll give an example. Imagine that you are a user of a popular social media platform and you see a post from a friend with a link to a very funny video. You click on the link, the video plays. However, after the video is played, after the video finishes playing, you are redirected to a malicious website that installs the malware on your computer or any device that you're using. So this is one example of cross-site scripting attack. The attacker injected malicious code into the social media post, which was then executed when you clicked onto the link, right? So excesses attacks can also be used to steal sensitive information such as cookies, tokens, I've mentioned, right, even credit card numbers. The possibilities are endless. And some of the examples of excess attack would be, an attacker injects malicious code into a search box or a vulnerable web application. When the victim searches for a term, the malicious code is executed on, and the cookies are, often stolen. Or another thing could be an attacker injects malicious code into a comment box or any sort of vulnerable website which has like a comment that is stored. When the victim views the page, the malicious code is executed and their session is stolen. Or another example could be an attacker injects malicious code into product review or any sort of reviews for a product in a e-cart or a shopping cart. Shopping application, and when the web victim views the page, the malicious code is executed and the browser is redirected to another malicious website which can again steal the cookies or tokens or card numbers, right? So there are a bunch of types of excesses, and one would be reflected excesses. So this type of attack occurs when an attacker injects malicious code into the web page that is reflected directly back to the user. So for example, in the example that I gave, right, an attacker might inject malicious code into a search query or a comment box, and when the user views that, it's directly executed. And stored excesses, that will be that where an attack occurs when an attacker injects malicious code into a database or a storage system or a system that can be repeatedly used. So the malicious code is then executed when the data is retrieved and displayed to the user. So in the example that I told, an attacker might inject malicious code to a forum or a post or a product review that every time you visit it, that's executed again and again and again. And the last one would be DOM-based access. This type of attack occurs when, let's say, an attacker injects malicious code into the DOM. DOM would be document object model of any web application or a web page. So the DOM is like a tree structure that represents content and layout of the complete page. So let's say when the user browses or user's browser parses through the DOM, it will execute the malicious code. right? That's DOM XSS. And yeah, how, like, what are the components that's needed to execute an XSS, right? So one thing would be events. This is completely in JavaScript codes, right? So one thing would be events. XSS events are events that can be trigger the execution of any sort of malicious XSS code, any sort of malicious JavaScript code, right? So these events can be initiated by the user, the browser, or even the server, right? Some of the examples would be onload, that fires when a web page has finished loading. On click would be it'll fire when the user clicks on any sort of element. On mouse over, that will be when a user's mouse hovers over an element or any sort of HTML. Yeah, it could be let's just say a button or anything on a web application. We have on input, on focus, on submit. That will be when a user submits a form in a web application, right? So there are so many events that can trigger this, and an attackers usually can inject malicious code into web pages and applications and then exploit XSS events to execute the code, right? So we'll have a quick video of XSS. So this is basically a shopping cart application. I'll give a quick explanation on how the cart works. We have multiple components, let's just say profile or cart or a catalog page, login page. So everything is different components, and it's connected by JSON API calls. And so this is the customer service. So you have a chatbot which will help you deal with any of the issues that you've found in the application. So we have a chat field. So here I am adding an XSS payload. The event that we were talking about is on error. So on error, we're alerting a pop-up, right? We're alerting one, and when we give it, the pop-up comes up, right? So this application is vulnerable to XSS. The SRC doesn't really matter, whatever input it is. That's why you have a broken image, and so the alert is popped up. So this application is vulnerable to XSS, right? So how is this vulnerable? Where is this vulnerable, right? So the input that is taken is directly appended into the inner HTML. Using the inner HTML, it's directly appended and it is run through a script, right? So the code is executed. What can be done about this? So this would be our solution. We'll come back to this after discussing a set of preventions that can be done. Yeah, what can be done? So there are a number of things that can be done to prevent XSS attacks. That will be validating all user inputs. So that will be like all user inputs should be validated before it is displayed on a web page or even stored in a database. This can include input from forms, cookies, and even search queries, right? Other thing that you can do would be escape all user inputs. That should be escaped before displaying or appending to the field. This will basically prevent the browser from interpreting the input as code, right? And you can even use content security policy. So CSP is a security policy that can be used to restrict the type of scripts that can be executed on a web page, right? And even use a WAF, that will be a web application firewall, that's like a security device that can be used to protect web applications from a variety of attacks, including XSS attacks. So going back to our fix, our fix would be to use DOM Purify, which is a library already available that will be sanitizing all the inputs that is taken from the user and then only appending to wherever the input is being displayed, right? So let's see how this fix works. So here we have changed the vulnerable code and fixed, added the fix here with the DOM Purify library imported. You can also download it and then add the value. So the input that is taken is sanitized using the Dawn purify and then appended. So now let's try to, add the comment, like add the exploit. We're using the same exploit that we used before. If we have our on error, right, so now you notice that it is not being executed. The alert doesn't pop up because it is not interpreted as a code. It is rather interpreted as a plain text, right? It is sanitizing the input that is taken. It is, and we made sure that it is not interpreted as the code. So that is one fix. We'll go for another example. We'll go for a different vulnerability. SSTI. Alright, so yeah, let's start with SSTI. So server-side template injection, right? It's a type of web security vulnerability that allows an attacker to inject malicious code into server-side templates. Alright, so templates are usually used to generate dynamic web pages, or let's just say you have hello, you give an input and you need the output to be hello, go pick up, right? So the input would be hello. It will be dynamically rendered, right? For that, we can use templates, and SSTI attacks can result in even code execution on the server, data theft, or even complete server compromise. So SSTI attacks generally exploit attacks exploit vulnerabilities in a way that templates are processed by the server itself. So I'll give an example. If an attacker, let's just say if we have a template engine and that does not properly sanitize the user input, an attacker could inject malicious code into the template parameter. When the server processes the template, the malicious code will be executed, right? Because the template will be processing it, giving the attacker complete control over the server. So SSTI attacks can also be used to steal data from the server. For example, let's say an attacker could inject malicious code into a template to read sensitive files on the server, such as it could be database password files, right? So suppose you are a platform. This is just an example. Suppose you are a platform, you are a user in a popular e-commerce website, and you add some items to your cart and proceed to checkout. On the checkout page, you enter your personal details, personal information, the shipping address. You may have also entered your credit card information for payment, right? So the website uses a server-side template to generate the checkout page. Let's just assume that it uses that. So the template contains a variable that represents the user's shipping address. The variable is again used to display the shipping address to the user and then calculate the shipping cost. So an attacker has the ability to discover a vulnerability in the template engine used by this website, right? The attacker exploits this, adds this vulnerability to inject malicious code into shipping address variable. When the website generates the checkout page, right, the malicious code is executed. It is not taken as any sort of shipping address or any text form. The code is executed. So the malicious code could steal the user's credit card information that you have, being trustworthy of the site, given it to the application, and the credit card information, and then it's sent to the attacker. The attacker then use the credit card to make fraudulent purchases. As simple as that, right? So we'll just go through an example of SSTI. So here we have a coupon code checker, right? So if you add the coupon code, in this application, what would happen is, in the service actually, what would happen is, when you give a coupon code, it will check if that coupon code exists or not, if that coupon code is valid or not, and it will be returning the coupon code. So this coupon code is not valid. So let's just say hello now, no, 5% off. So 5% off is not valid, would be the response from this template, right? So what can be done about this? How can we exploit this? Yeah, so you give hi and then it is responding hi. So rather than the input, when we give value. This is basically just checking if the commands in the template would be rendered as commands as such. So if you see the config that is checked, this is be using Flask. In Flask, so config will be giving all the configs, right? And when you have given config command as the input rather than any coupon code as such, it's giving out the complete configuration of the file. So what more can be done with this, right? So a vulnerable template that is rendering the command as the code. So what is the problem? Where is the problem here? Alright, so this is a vulnerable code. You can see that it is taken as render template string. The render template string would be taking it completely as the string and appending it to the backend. So it is directly appending it to the template. So this is a major vulnerability that can lead to server-side template injection in Jinja or Flask, Jinja 2. So what exactly can be done about this? For that, we'll quickly discuss a bunch of security issues and then come back to the fix. Yeah, so there are a bunch of things that can be done to prevent server-side template injection. It will be, again, sanitizing all user inputs, and we can even use a secure template engine. Just choose a template engine that provides built-in security features. Right now, Flask mostly doesn't allow any sort of template injections, and security practices such as output encoding and sandboxing, that's already done. And keep your security and template engines up to date. They're always releasing a new set of engines, and make sure that your template engine is up to date and having the latest security patches. And train your developers on security SSTI vulnerabilities, because this is one of the most common vulnerabilities are actually in our organization, and educate the developers on the risks of SSTI attacks and how to prevent them, right? So what will we do in our current situation, our current issue, right? So rather than using the render template string, we can simply use this function that is render template, that wouldn't be taking in the input and directly appending it, right? It will be taking it will not be taking the input as the direct string, or that when appended would be executed as a code, right? This would be an input from the user that is appended, and it would not be executed. So here we can modify the code and check if the render template works. You just go to the demo. So we've appended the code, and you can notice that it is not executed. Whatever input is given is directly printed out. It is printing it out rather than executing the code. Before, in the render template string, it was like rendering the input completely rather than just printing it out as a string, printing it out as it is, whatever input as that is given, right? So that's one of the fixes that you can have for SSTI. Now we'll go for another vulnerability. Yeah. So LFI, or local file inclusion, is again a vulnerability that allows an attacker to include malicious files that are already locally present on the server that might not be accessible to the public, right? So it will be locally present on the server. Through the exploiting of the vulnerability, it can include all these procedures that can take out the target application, right? So this vulnerability usually occurs, for example, when a page receives as an input the path to the file, or any sort of image. It could be image or any sort of file that has to be included, and this input is not properly sanitized, allowing directory traversal, like it could be dot slash that can be injected, and there can be a path traversal to leading to any files that should not have been publicly accessible to any user, right? So LFI attacks can actually be used to steal sensitive data such as database passwords or even configurations files. That's a huge leak, or even to actually execute arbitrary code. Let's just say you lead to that page and you inject a file, and then you can actually execute a remote code. You can actually manage a remote code execution there, and this can lead to complete server compromise and data breaches, right? So we'll go through a small example of local file inclusion. Yeah, so this is basically a search bar, right? Whatever we're searching, whatever page we're searching, if at all that it is there in the application, it will be rendered, it will be printed out, right? So yeah, I'm searching for a page that doesn't exist. So if at all that page exists, let's just say we're searching for a page test, it doesn't exist, so it is not executed, right? So let's just say this file 1.php does exist. So when you search for that, the file is being rendered out. So if at all the page exists, it is rendered out. So I'm trying to do a path traversal here and read the etc password file. So as easy as that. So since the parameter page was vulnerable to local file inclusion, it was simply just rendering whatever pages are available. And is /etc password available? Yes, it is available in that server, and it is being executed, right? There is no check on what the input was, and it is being executed. So what can be done about this? So yeah, we'll just quickly go through what the issue is. File get contents. We can have file get contents include. These are a bunch of functions that will be rendering the page, rendering pages, right? And imagine rendering the pages in the pages parameter. It is user input. You cannot blindly trust a user. A user can be an attacker who's giving out inputs, malicious code that will be triggering the endpoint that should not be accessible by the attacker, right? So usages of file get contents or even include these functions are vulnerable, right? These functions without taking an input without any sort of sanitization are vulnerable. And yeah, so the issues, the preventions of this issue, again, sanitize all your inputs and probably use a secure scripting language. As here, some scripting languages such as PHP are more vulnerable to local file inclusion attacks because it doesn't exactly consider the input as like a string. It's rather taken as a code, right? And if possible, use a security, a scripting language that is less vulnerable to LFI attacks, and make sure that you disable directory listing. So when you're traversing the paths, you can actually check what and all are there in the current directory and exploit, right? Brute forcing, yes, is possible. That is possible even if the directory listing is disabled, but this is just a safety measure, right? This will prevent attackers from seeing a list of files on the server, which could make it easier for them to attack, use the file. And make sure that you keep your software updates. It will often include security patches that can help to protect LFI attacks. And firewall web application firewalls that can again be used to protect your web application from a variety of attacks, including LFI attacks. So our code fix here, yeah, so here if you notice, rather than just directly giving the input into the page parameter, we're doing a regex check, making sure that there is no characters like dots or slashes or any sort of special characters. No, that should not be included. We'll just make sure that only alphabets and numbers are the ones that can be inputted into the parameters, right? And we're also doing an HTML special characters that will escape the input, and this is a proper sanitization method to make sure that no special characters can be used to exploit this vulnerability, right? So after we append this code, we'll just quickly check the fix. Yeah, we've changed the code and we've added this code instead of the vulnerable code. So again, if when we try to check for tests, it is not available, it is not giving out the input. So now when we give our exploit, right now when we are adding our vulnerable parameter as such, it clearly shows that it's an invalid file request, because there is a lot of characters that should not be allowed, right? The regex checks make sure that those characters are not allowed. So that is one of the fixes. We'll go to the next vulnerability. Okay, so next one is insecure file upload, right? It's again a vulnerability that allows an attacker to upload a malicious file to web application, right? This can be done by exploiting a weakness in the application, application's file upload mechanism, right? So when an attacker uploads a malicious file, it can be executed on the server, which could give the attacker complete control over the server. The attacker could use the malicious file to steal sensitive data, use a database use it to get database passwords, and even customer information. So a real world scenario of insecure file upload attack would be, let's say a popular social media platform has a feature that allows the user to upload profile pictures. The platform does not properly validate the file type of the uploaded profile picture. This in turn allows an attacker to upload a malicious PHP file disguised as an image file. So when a user views the attacker's profile picture, the malicious PHP file is executed instead of the image being rendered, right? So this gives the attacker complete control over the server and allows them to steal sensitive data such as passwords or credit card numbers. So in a realistic scenario, an attacker discovers a vulnerability in file upload mechanism of a popular e-commerce website, and the attacker exploits this vulnerability to upload a malicious PHP file, right? As simple as that. And when executed, let's say the user visits the website and adds an item to the cart or adds their credit card numbers, the malicious PHP file can actually steal the user's credit card information and send it to the attacker, right? So I'll just quickly show an example of this. Okay, so we have an application that basically takes a profile picture. It allows JPG file, JPEG file, PNG files, and zip files. Anything other than that is not allowed, right? So how can we bypass this vulnerability and add, let's say, a malicious PHP file that can be used to exploit this application, right? So we intercept the data and we simply just change. So if you notice here, content type is text/PHP. That tells the browser, it's a header that tells the browser that okay, whatever input is given by the user is a PHP file. So if it is given as images/JPEG, it's basically telling the user, it's giving the information that okay, whatever file that is incoming, that's a JPEG file, that's a PNG file. So we simply change the content type and send the request. So when we forward the request, we notice that the account.php file is uploaded, right? It doesn't exactly tell throughout the error stating PNG files are not allowed, JPEG files are not allowed. Only the PNG and JPEG files are allowed. It doesn't show that. It clearly shows that the file is uploaded. As simple as that, because we tricked the server into thinking that okay, whatever file is coming is a JPEG file, even though it is a PHP file. So what exactly is wrong? Where did we go wrong with this, right? What is the vulnerability? Yeah, so if you notice, all that it is checking is the type of the image, right? It just checks if the header, whatever is coming, is that's the only thing that is checked. That's a good check, but this definitely needs more than that, because one blacklisting is not the best way to go. One blacklisting and you have like 10 bypasses for it, right? So we notice here that it's checking if the content type is image/PNG, is image/JPEG, is image/JPG. If it is, you're passing it and you're downloading you're uploading the file, right? So as simple as that. The bypass is as simple as that. So what can be done about this? What is a fix that we can do, right? So yeah, again, there are multiple ways to prevent insecure file upload attacks. Validating input will be the best thing to do, and make sure that you restrict file types, right? Here you're restricting file types by just checking if the content type is PNG, JPEG, right? That's easily modifiable when you can simply just intercept the request and change the headers, and make sure that you rename uploaded files. So with the first example that I gave, let's just say you have a file that is uploaded and you go to the file and you're executing the code. So make sure that you have a very random large string that's the name. You'd rename the file, so the possibility of an attacker accessing the file is very less, right? And make sure that you store uploaded files in a secure location, a location that is not accessible by public, right? It shouldn't be accessible by public. It shouldn't be an endpoint which should be accessible by the public. And make sure that you have a web application firewall, the firewall that protects your application from a variety of attacks. That'll again include insecure file upload attacks. So yeah, here the modification that we made, the fix that we added to the code. So we're making sure that rather than just the content type checks, we're making sure if the file already exists. We're making sure if these are the sets of extension types that's coming. We're checking for the mime type, right? So these are actually a good set of fix, and we're checking the file mime type and mime content type. That's the function, the pre-existing function that can be used to check, and it recursively checks if it iterates to the array and checks if it's a JPG, JPEG, and PNG or the GIF file, right? So we can implement the fix using mime content type check, and make sure that it isn't any PHP file that uses a header that is a false image file. That is not allowed. So let's see how this fix works. So we've added the fix to the code. So right now it is not just checking for the content type. Now when we add a random file, that's an HTML file that shouldn't ideally be accepted. We can still change the content type. We can still change it to images /png or JPEG and forward it. So now we'll actually notice the second check, right? Even if you add a .png extension in the end, it will not work. It will check the mime type and it will tell that okay, only JPEG, JPG and PNG files are allowed. Even if you plainly change the extension, even if you bypass the content type, the extension type, you still have the mime check, right? So as simple as that. That's a fix for this. So we'll just conclude our talk. Concluding, again, developers should be a part of DevSecOps because they are the ones building the software. They are basically the building blocks, right? They have the deepest understanding of the code and the system architecture. So this just basically makes them uniquely qualified to identify and fix security vulnerabilities. Just that the awareness is not there. It's always we teach the security engineers what is the security best practices, but imagine doing it from the start, doing it from taking an initiative from the developers, and with the amount of potential they have, with the amount of fixes that they can do, rather than going to the traditional practice, going to the pen testing, sending it back. It's just increasing the SDLC's software development life cycle, right? So let's all go ahead and educate developers about DevSecOps, integrate security into the development workflow, and promote collaboration between developers and security engineers, and make the digital world a better place to live, right? So with that, I conclude my talk. Thank you all for taking the time to come today and listen to my presentation. I really appreciate your attention and your participation. I hope you learned something new today, and I encourage you to put forward make use of whatever you learned into practice, feel free to drop a message to my Twitter for any queries. And thank you again for the team for the conference for hosting me, and thank you all for the support. Yeah.
students, I also work on animation because that's kind of the funding model.
If you're curious about the title PhD researchers,
That's this.
PhDs
That's
change
here.
their title as they move through their education.
Recording.
So you're a PhD student before quals.
This is the
After
capture
quals,
card.
you're a
Wait, just
PhD
go to
researcher.
input devices so we can
After
see
you're-
all of them at once.
After you propose,
Yeah, that's
you're
a better idea.
candidate. And then once you defend it,
That's
you
not giving me
become a
anything.
doctor.
That's giving me
Traditionally,
nothing
you
aside
get your
from
title after the final defense, and your advisor will go out and say, "Congratulations, Dr. So-and-so." And that is how you know you passed. If they come out and said, "We'd like a word with you," you're in trouble. Because you only get so
The
many
mic is
shots at a
definitely
defense
on.
before you are basically kicked out
Well,
of the
all of these are
program.
turned up to 100%.
So
It's not
what
giving me anything
happens
over
when your
USB.
advisor walks out after each proposal is a very big
What's
deal.
privacy?
Traditionally, that is when your
What if we
friends
turn that off?
employ
Is
their
this still
best dad
privacy?
jokes
Oh,
to keep
hang
you
on, wait.
entertained while
Come
you
back.
nervously pace the hallway and hope that you
No,
not just
that's
wasted
we
60
only have the internal mic.
Okay.
I'm not really selling the
let's just
PhD
unmute all of these.
experience here, but
Might as well mute everything. Okay.
I do not get a sword
Does
at the
any
end.
of that give
Apparently,
us
I think it's in
ambient
Norway.
noise or
If
something?
you get your PhD, you get an actual physical sword.
Really?
Yeah.
Dang.
In Sweden, your
That's-
defense
that's
begins
off.
with someone entering
Yeah.
carrying a mace.
The buttons here.
Yeah, I got it.
Okay. You're good.
It's apparently a battle
Wondering,
mace, but
like, we just
hopefully no one
unmuted
uses
Yeah.
it.
everything, right?
Supposedly in the Middle Ages.
That's not giving me anything.
these
I mean, that's going over the
would
overheads, but that's not
actually-
Yeah.
going into
they get
USB.
called
Yeah.
defenses
Is this the right USB
because
plug?
someone
I don't know,
actually
maybe
might
not.
speak.
Okay, I have to go run
You have to
Hans's
go, no,
talk.
defend your
Just
ideas,
Can we
defend
switch? I can run Hans's
yourself.
sure. Yeah, he needs a timer, and I have a question,
Okay.
but it's
here,
fine. I can.
mean, if
It's
not,
Hans.
can-
I can talk to him later.
Yeah, sure.
Yeah. So you're good, and then we can't get either. They're not sending us input
Yeah.
to this computer. So there's a built-in mic on this laptop, which I can crank up a bit.
Okay.
And then, would you please speak at a normal volume? Just like speak how you would during your talk.
Hello, world. Who's awake?
Okay. Yep. That's
There we go.
very loud. I'm going to actually turn it down a little bit so that I don't clip you too hard, and I can boost you up more in post. I can give you a gain without clipping you too much.
Do your best.
Yes. Sorry for making you late.
As long as you're the guys who wanted to get back on schedule, so as long as you're cool with it, I'm
Yep,
cool with it.
we're great.
And I'll try to move with alacrity.
Okay, and we're gonna go ahead and actually mute these so that we don't get any feedback. What does alacrity mean?
Speed.
Okay,
Swiftness.
it's the name of my terminal. Thank you.
All right. So without further ado, welcome to a general introduction to fuzzing for developers. This is the first time I've given a fuzzing lecture for developers, so we'll see how this goes. So we're going to do introductions, although I guess we started a little bit while you're waiting. We'll talk about why you're here, what I hope you'll learn. We'll break down a fuzzer. We'll talk about who's using fuzzing and why, because it's an important thing to understand. We'll talk about some optimizations. We'll talk about integrating fuzzing into the software lifecycle, which is the expanded section of this talk. Unfortunately, like many punchlines, it's at the end. And then there is an optional lab at the end. At conferences, I know we tend to drown you in information, so if you were like, I want to take a picture of the lab and I'll do it later, it was funded by the NSF. It's up on the internet. Whenever you feel like doing it, it's there. You want to wait for Christmas break? That's cool. So who am I? I am all these things, but more importantly, I have been involved in open source for a good 2 decades. Both my internships at Cisco and Amazon involved free and open source software. I spent the majority of my time at Mozilla. Signal Sciences, now Fastly, Wall came from something called libinjection. So even there, although it was a closed source version of an open source thing, we still did open source software. Questions about this? Since this is the smallest audience I've ever had as well, we can do this more interactively, and I kind of hope we will. Holding forth into the void is not particularly pleasant as an instructor, so if I say something strange or use a piece of jargon you don't recognize, throw your hand up or yell at me. Either works, not going to hurt my feelings. Sounds good? Yeah, okay, cool. All right, who I think you are. I think you have some developer experience, or maybe you're a UW-CS student. I know we have a few in the audience. If you're an expert in security, I'm going to bore your pants off. Sorry, not sorry about that. And I'm hoping that you've at least heard the word fuzzing, but you might not know what it is. Sounds about right? Cool. All right, so our goal of the talk is hopefully to frame your thinking about fuzzers. And hopefully avoid being prescriptive. I don't really like it when talks do like blindly do A, B, and C. We are software people. The answer is always why, so that you know when you have the appropriate situation to apply a tool. You shouldn't only have a hammer in your toolbox. The world is not made of nails. Sometimes we encounter screws. I'm not a hardware person. That's the extent of the analogy I can do. But you sort of get where I'm going. I hope you learned something. And I hope I'm mildly entertaining. I hear I'm funny. Only funny when I'm not giving midterms, apparently. I hope you understand that fuzzing is still more craft than science. We still don't know a lot about why fuzzing works so well. A lot of it's heuristic, a lot of it's sort of experience. I can't really give you hard science the way I can and say, like, your programming language class or your algorithms class. We are still learning things. And hopefully you'll be able to apply some of that learning by the end of this talk. But more importantly, based on my interaction with the open source community and fuzzing, I hope you understand that patience is a requirement, not a virtue, when dealing with fuzzing in open source. We'll get into why that is a little bit later, but all right. So let's start with the motivations. I really hope I don't have to convince you that bugs are bad and vulnerabilities are extra bad. We also don't scale. There are simply more people writing code than people who know how to analyze or fix it. Sound about right in your experience? Yes, no? Cool. Well, in particular, my advisor loves these particular articles where Linus Torvalds lauds fuzzing. I'm going to guess you probably know who that is. We also estimate that there are approximately 1 bug written per every 100 lines of code. And based on some research, we know that is, from a paper called AFL Churn, we know that is true regardless of the age of the code base or the experience of the developers. My team is smart, we don't write bugs, is bullshit. I hope that's also not a surprise. All right, so how did fuzzing get invented? Well, it was a dark and stormy night, sort of like earlier, but at night. I don't know if you guys heard the lightning. That was pretty spectacular. A young professor was trying to work from home, which in 1989 was a novel thing that really only weird people in CS did, when lightning hit a telephone pole, and it dumped a bunch of junk into his terminal and crashed the program. Now, as I'm sure you all know, one thing no program should ever do is crash. You can all agree programs are never, ever supposed to crash. And that left him unable to finish the paper he was working on. So what's a poor professor to do? Well, you know, your CS students always need final projects. And it's a time-honored tradition to take your problems and have your students fix them for you, and then you write a paper about it. And thus fuzzing was born. He gives this problem to his students in his OS class, and two groups take him up on it. One group half-asses it. No one has a clue who they are. Well, I guess Bruce probably knows who they are. They were his classmates. But the 3 that actually threw their all at their final project and did the best they could end up with the publication, and now can say they are the fathers of a billion-dollar field. Students, don't half-ass your final projects. If nothing else, they're great things to talk about in your interview, and you might start a whole new billion-dollar field. I'm serious. This was a pair of students. All right. Now, the reception to this paper is especially poor. By the way, it's a magazine article. In fact, I should remember I have props. It is this magazine article. So feel free to have a look through. And if you write C code, I recommend reading it because it talks about common mistakes and issues they find in the code base. But anyway, the reception is in fact so poor that a reviewer tells Dr. Miller that he should leave the field. So if you ever got poor review on code, at least no one's ever told you should quit CS. However, the security community picks this thing up and runs with it. Right. The operating system and the systems community in general ignores fuzzing for about 2 decades, but the security community is putting that sucker on the map. The one that most people have heard about first is something called AFL. It stands for, wait for it, American Fuzzy Lop. It's a type of bunny. We really like naming fuzzers after things that are fuzzy. If English is your second language, that's because this is a homophone. Also, I cannot convince Google that I do not want the Australian Football League. Naming software is hard. Anyway, there are various theories as to why AFL becomes the dominant fuzzer and arguably the most successful one in the world. I won't bore you with them, but if you are a developer, I really recommend reading the 30-year retrospective. The first fuzzer was not particularly smart. It was written by 2 students for a final project on top of their other classes. It's not super complicated. I think it's a thing that most juniors or seniors could write for their final projects if you have a look at it. But even 30 years later, it's still remarkably effective. And if you saw the Rust talk earlier, they also break some Rust code with it. So the Rust is not going to solve all your security problems. Cool. So what is this thing called fuzzing? If you are a diagrams person, here is a diagram. But if you prefer definitions, fuzzing aims to thoroughly explore the input space of a target program, or fuzzy, or sut, or put. We can't agree on what to call the thing we're trying to fuzz. Looking for inputs that cause interesting behavior. We call those inputs seeds. We have our own jargon, of course. As you can see, it's somewhat inconsistent. However, the definition of what is interesting behavior is actually an important feature of what makes a particular fuzzer tick. So it'll have its own slide later. And this is a stochastic, which is a probabilistic, dynamic software testing technique. You have to run code to fuzz. If you can't run the code, you can't really fuzz it. Make sense so far? Questions about this basic definition? At its core, we're going to take some inputs. We're going to feed it to the target. We're going to see if it does anything interesting. We'll hopefully do something with that information, and we're going to repeat it. Yeah, what's up?
Oh, sorry.
Oh, okay, cool. I was like, someone's taking me up on the questions. Yay! Even if a fuzzer is like super sophisticated and has AI pixie dust, they all fundamentally follow this basic cycle. The idea at the core of fuzzing is not actually a very hard one. We're just going to gin it up with a bunch of bells and whistles and extra stuff. But does everyone sort of get the core idea? Okay, cool. All right. Another thing worth talking about, especially since kernels are a big thing for this group, is something called a driver, or a harness. This is essentially a translator between the stuff the fuzzer comes up with and the thing you're trying to fuzz, or the fuzzy. So if you are familiar with the Monty Python sketch, it's basically the Hungarian translation book. Gonna kill all these jokes. Sorry. Drivers are actually very important. Not all pairs need one, but if you do, they are very important and they can be a non-trivial amount of work. Imagine there are 100 doors. If you knock on only one, are you going to find the bugs behind the other 99? No, right? You can't find the bug behind a door you didn't open. So harnesses are often part of how we open all the doors. All right, the general fuzzing workflow. I am a terrible artist. I'd love to say we are glad I do not get paid to draw things. First thing you're going to do is setting up the target, setting up your software. You're going to probably debug your setup with some short fuzz jobs to make sure you got everything the way you want it to. Particularly want to make sure your operating system does not execute you for overuse of memory. The errors are the bane of my existence. You're going to fuzz for real. And this is often fairly long, think 24 hours to a week. You're going to review and check your results. Not all results are reproducible. We call it the crash triage or reproducibility problem. Just because a fuzzer crashes on an input doesn't mean the next time you run it with that input it's going to crash. Sometimes there's an internal state that's corrupted and the fuzzer just doesn't know. It's like, I got this input, I got this output. Hope it works again. Have fun, guys. And as if you are someone who's stuck with the bug, this is an important thing. You're optionally going to analyze it. Fuzzers rarely know why. So if you want to know why something crashed, that's all on you, the end user. We call this the root cause problem. It also means there's often duplicates or missed things because the fuzzer doesn't know why. It usually looks at the stack hash and goes, that looks like a stack hash I've seen before. That might be the same bug. Spoiler alert, it's a very bad heuristic. Hopefully you'll do something with the fuzzing results. You're going to attack, report, maybe tune the fuzzer because you didn't get the results you wanted. Hopefully you do something as a result of spending all the CPU and RAM power trying to fuzz the software. Make sense? This is a step that people sometimes forget. They're supposed to actually do something with the results of fuzzing. And you're going to repeat this cycle. And that's why there's a bunny, is because American Fuzzy Lop's a bunny. Questions about this diagram or this general workflow? Looking good? Cool. All right. Now that we've sort of gone through fuzzing we're going to break down a fuzzer. How to understand what fuzzer you're looking at and how it does. First question is, what is interesting to this behavior to this fuzzer? What is this fuzzer looking for? The typical answer is usually seg faults, but we have something called property-based testing in the PL world, and that's looking for counterexamples to proofs. Crashes are not actually necessarily a counterexample, and they don't care, but they are interested in counterexamples to properties about a program, hence the term property-based testing. How does the fuzzer get new inputs? Where do the things to test come from? What's its exit condition? When does the fuzzer stop? How much does the fuzzer know about the fuzzy? And I call it fuzzy source here because that's usually the thing first people want to know. But this is also a broader question about how much does the fuzzer know about the fuzzy? What can it observe about its behavior? If it can't observe much, your fuzzer is probably not going to be as powerful. And does the fuzzer have a specialty, a pixie dust, magic? AI is really popular right now. That would be a form of pixie dust. You know, when someone's like, my fuzzer is special because it does X, Y, and Z, that's in bucket 5 here. So, what do we got? Our most common form that you will see is something called coverage-based. This works on the assumption that the more code you cover, or exercise, depending on how you put it, the more bugs you're likely to find. And we do this usually with tuples. We'll instrument the binary with code points, and we'll look for pairs. All right, so you can see we have the first 2 paths, A, B, C, D. We see A, B, C again with seed 2. We've already seen that. We don't care. But seed 3 here exercises a new path through the code. That makes seed 3 more interesting because it's a path we haven't seen before. So that's what coverage looks for, new paths or new areas that have been covered. There's an assumption here because we do this with unique tuples. We don't usually have path information. The other kind you'll see that I think is very interesting to developers is something called directed fuzzing. That's where you stick a point here and say, this is my goal. The closer you get to here, the more interesting you are. And we like those because you can say, here is my newest commit, or here is my parser, or here is stuff that we think is really old and dangerous. Go poke at it. And it will attempt to pick seeds that get you closer to the goal point. Make sense? That's why we call it directed fuzzing. It's directed to a point. Taint analysis is actually something very old. It's an idea from the 70s, and that's where you attempt to follow paths from input, which are tainted, to a source, which might be etc password, flag.txt if you're in the CTF world. But the thing that is almost always interesting is crashes, because it is assumed that programs should never crash. So sort of if there are universal assumptions in computer science, it's that programs should never crash. Thus, anything that crashes your program has violated an important property and should be reported. So if it sets your binary on fire, it's usually considered interesting. Does this make sense? Like, there are different ways you can define interesting here. You'll usually have more than one fuzzer. So like, this is not an either or, there are many ways to define interesting, and they are sort of specific to particular fuzzers. If you're ever going to pick a fuzzer and say, is this good for my use, you want to ask, what is it after? What does it find interesting? Because if it's not what you find interesting, it's not going to help you. All right, where do new inputs come from? Well, there are 2 sort of big ways that this works, or I guess 3. The original was down here. Sorry, microphone. This is the classic version by Dr. Miller and its students, and it just grabs from dev.rand. Sticks some stuff in it and sees what it does. It doesn't really have a memory of what worked. It doesn't care. The most common form right now is something called mutational, or mutation, and that starts with you give it some sort of seed, you try it out. If it works well, you're like, hey, let me twiddle some bits and try that again. So in our high level here, we start with a basic cat with no whiskers. We try the cat with whiskers, and he does better. So we're like, let's give that cat 100 whiskers and see if it does even better. Generational is sort of something where you have a starting algorithm. You're like, okay, I need a face has 2 eyes, a nose, and 2 ears. I have a set of eyes, ears, and nose. Let me try to combine those in interesting ways to meet the specification and test that on the target, right? We call those generating because you're sort of generating from a base algorithm or specification. So HTTP fuzzers tend to follow that because it has a specification. Make sense? Sounds good? Cool. Exit condition. These are not as interesting, but I think it's always worth thinking about. Usually we use scheduled duration or user-initiated exit. This fuzzer will run until someone tells it to shut up. Now, it is theoretically possible for a fuzzer to run out of inputs to test. I have only seen this once, and the program in question was a car, and it took a 16-bit integer. You can brute force your way through all 2 to the 16 bits, so that's the really only one I've ever seen run out of seeds, but it's theoretically possible. And there are fuzzers that will find one crash and exit. They don't keep going. The biggest one is libfuzzer. Libfuzzer is meant for developers. It's assumed you will fix the crash. So offensive people hate it, and I'll get to why later, but yeah. All right, and what is the fuzzy you know about the fuzzy source? If you've ever noticed, fuzzers often have these very long multi-adjective descriptive names. Well, one of those is usually white box, gray box, or black box, and that refers to how much the fuzzer knows about the target, or the fuzzy. In white box, you have the source code, you have the world, you can do whatever you want with it. You can analyze the source, you can augment it, you can stick a whole bunch of stuff in it. In black box, you usually have the consumer end product, the highly optimized, usually binary. It does not have the source program, it does not have the developer comments, it has no documentation in it. It is as optimized and as stripped of information as possible. Now, I'm sure as many of you know, as a program moves either through interpretation or compilation, we drop information that we no longer need in the name of efficiency, speed, and space. So if you're working with black box, you're usually working with way less information about the target. Make sense? In the middle is something called gray box, so something that sort of rose to prominence alongside AFL, and that is where you have the source, but the thing you're actually going to run is a binary, and you're going to compile a whole bunch of instrumentation in there to help the fuzzer do its job. That's where we get those code points used for code coverage, is usually something like gray box. So you have the source, you compile it, and the thing you're running is running a binary, so it's faster, but it's also got extra stuff in it. Usually to do gray box, you do need the source code. That's not always true, but it's often true. Make sense? All right, and then the 5 is sort of this grab bag. Does this fuzzer have a specialty or focal? We have fuzzers that are special to HTML and HTML5 specifically. We have one aiming at firmware or routers. SysColor is one I imagine many of you know. This is the fuzzer for the Linux kernel. BooFuzz is a white box HTTP fuzzer. Again, if you do a web app, BooFuzz is popular. And of course, the car I mentioned. Bonus points, UW students, if you know where on campus that is. That car had its own fuzzer. What's up?
Thank you for saying SysColor out loud so I know how to pronounce it.
You're very welcome. Yes, it's pronounced SysColor. It's a cute pun. All right, so let's apply that to a fuzzer so you can sort of see how this breaks down. For AFL or AFL++, what is interesting behavior? Well, system crashes, also known as seg faults, and new coverage. It's a coverage-guided fuzzer. Where does it get its inputs? It's a mutational fuzzer. It mutates prior inputs to get new ones. And it has dozens of mutational strategies in there, but at the core, it's a mutational fuzzer. You have to have existing inputs to make new ones. What's its exit condition? User exit. But the bane of my existence, as I mentioned, is errors. A lot of fuzzers use a lot of memory and a lot of resources. So if you are very not careful, you'll run into a lot of times your fuzzer is killed by something other than you. And then how does this one know about the source? It's gray box. You start with the source, you heavily instrument the binary, and the thing you're actually running is a binary application. It's usually built from source. And it is meant for compiled userland binary applications, most commonly C applications. We use GCC or Clang to compile them, although people have written other things that will let you build other things that way, but like AFL's specialty is compiled userland binaries. There's a kernel version called KAFL, there's QEMU-AFL, there's a whole bunch of ways we have tried to shove other problems into it, but its original target was userland C binaries, on Unix systems in particular, although someone's ported it to Windows. It has some 20 research papers worth of ideas into it, so it does a lot of tricks. But you have to know to go turn those tricks on. So it takes you maybe 20 minutes to set up AFL, and it takes a lifetime to learn all the tricks it can do. Questions about that? Doing my best to go as fast as I can since we started late. What's up?
I just wanted to ask, maybe this is too much for one question, but for mutation strategy, how do you choose the best?
Okay, so the question was, for mutation strategies, how do you choose? That is an art form, my friend. One of the things I'll talk about later is how to maybe pick mutation strategies or tell it you want mutation strategies that you think are good for your target. Part of the craft is sort of being able to say, I really want these things for my target, and some of that is on you as the user to supply features. So we'll talk about word lists a little bit later. You can often give it like keywords. So if you know the target takes XML, giving it a list of XML keywords is very handy, and that's part that you can do, and that helps guide the mutation because you give it more to work with. So that's the art and craft of it, less the science, because a lot of it's heuristic and a lot of it's experience. Is that? Yeah. Sorry, there's not as much concrete information there because it is an art. All right. So, who's here? Not everyone uses fuzzing for the same thing. Not everyone has the same needs or the same uses. So before you can pick a fuzzer, you have to figure out what your needs and goals are. When I first got started in fuzzing, I was very confused because I'd see articles or blog posts like, this fuzzer is great! And then the same people are like, this one is crap! And I was like, it's the same one! And the reason is those two audiences, the two authors, had very different needs from their fuzzers. And just because a fuzzer is a great fit for one crowd, it's not necessarily a great fit for the other crowd. So, who's using fuzzing? So, as I mentioned earlier, it's offensive security that really put it on the map, although PhDs in operating systems invented it. And their goals are this. They want to find at least one vulnerability, preferably more. They want to find them fast. And they give 0 Fs about why. They do not care why this thing breaks. They only care that it breaks consistently, so they can put it in their exploit chain and get on with their day. They're going to look for this type of features. They want things that finds vulnerabilities. Bugs are a waste of their time. If they can't exploit it, they don't care. They want to find them fast, and they would prefer source code not be required. Makes sense, given that they're just trying to break into things. This, like their list of things, does not care about why. They don't care about bugs. They often don't have source for fairly obvious reasons. And so here are fuzzers that might interest that crowd. Now, a thing I was sort of shocked at when I was a guest speaker at the Linux Security Summit was the reaction of the community members to the security community. There were a lot of people who were very upset that people who find vulnerabilities want to be paid for them. Maybe don't be too mean to them because this is how they feed their kids. So even if they like open source, there are only so many they're willing to give away. Anyone want to guess how much a Linux kernel vulnerability can go for?
10K.
We got 10K. Who wants to place another bet? All right, what do you think? 60K. Try 20 million. In a non-NATO country, particularly Russia, a 0 day in the Linux kernel with root, they can read the root RCE is worth up to $20 million. Google paid out $12 million for Linux bugs in 2022. They give a low price of $100,000. If you want to give it to someone reasonably ethical who's going to fix it, it's $100,000. As a PhD student, that is nearly 10 times what I make in a year. So if this is your freelance thing, this is your job. And you also have to cover all of your bills. Fuzzing is not necessarily easy or cheap on your hardware. So please don't hate these people too much if they want to be paid, because that is a lot of money to walk away from. All right. So another group you hopefully encounter nowadays is something called the defensive security. They work for the company or the project with you. They want to find all the vulnerabilities. They do care about why, because their job is to convince you, the developers, to fix them. And they're going to look for this thing to sort of fit into their existing security protocols. They're okay with finding bugs, but that's realistically not why they get paid or why they work on a thing. So bugs are okay, but not great. Make sense? Like, they're kind of got a foot in both camps. Now this is us, or, well, yes, I am a fuzzer author, so I guess I am also a software person. Was for most of my career. If you are in software, you want to find the vulnerability, sure, but you also want to find all the bugs because they're still your problem. And this group, including me, really cares about why. And this is somewhat unique in the fuzzing community. This group cares about why, because I'm sure you are all familiar with someone calls you and say, hey, I got a bug, and you're like, yeah, that's cool. And so people who are fuzzing for software are looking for something else. They're often looking to target a particular commit because that's how we generate code. And if you think code is risky, you might want to fuzz a particular commit. CI/CD integration is a tough thing in fuzzing, but it'd be great if we had it. We're looking for stability. We'd like to find bugs and vulnerabilities, and this is kind of unique. Everybody else is just looking for vulns. Things like snapshotting and time travel are great for debugging if you can get it. And code coverage is this is the one group where code coverage actually matters, because we generally care about it because that's our test coverage. Make sense? And then fuzzers that might interest you are in this list. In the interest of time, I'm not going to go over them in particular, but I'll put the slides up on GitHub afterwards so you can go through these at your leisure. And this is the group I'm currently part of. Our objectives often look like other groups. I am a developer at heart, and that's where my fuzzing development objectives really are, but you might be studying other things in CS. Fuzzing is just sort of the topic. You're looking for benchmarks, you're looking for publishable, you're looking for citable, because we don't graduate from being great teachers, we graduate from doing novel research, and you have to publish it. And then if you're a fuzzing person in that area, our two big go-tos are libafl, VMF, and you're going to ultimately write your own, because again, that's how you write papers and how you graduate. I would like to graduate. All right, questions about the 4 main groups in fuzzing? Cool? All right. Optimizing a fuzzer generally. I'm going to breeze through this one. Your harness matters. I mentioned that earlier. One of the things they tell you in teaching is you should repeat something 10 times more than you think it should, and then maybe half your students will get it. So if I sound like I'm repeating myself, that's deliberate. Help the fuzzer help you. Spend time on the parts that make the fuzzer tick. That's why I spent the time going over the different things, and people are like, how do I make my fuzzer better? I'm like, well, what type of fuzzer is it? They're like, I don't know, it's a fuzzer. I'm like, well, if you're going to try to optimize parts of it, you have to know what makes it tick, at least in broad strokes. So if you've got a mutational fuzzer or a generational, you're going to do different things than if you got a generational fuzzer. Focus on beefing up those features. If the fuzzer you're using has special features, you want to see if you can turn any of those on, if they'll help you. And please keep track of what works and what doesn't. As I said, this part's way more craft and art than it is science. You're going to learn from experience. And if you are working with the same code base, you have the luxury of being able to try lots of things and see if they work better. AFL has a powerful feature called complog, which attempts to get out of a problem we'll talk about later, but it's actually very dangerous not dangerous, but slow, dangerous to your performance on certain things, and you have to know when you might want to turn that off. And generally, making more things crash, because all fuzzers agree that crashing is interesting, is generally in your best interest. If you remember nothing else from the slide, if you have a sanitizer, use it. But wait, this is intro talk. All right, who knows what address sanitization is? Okay, about half the room, so I'll go through this quickly. So, address sanitization is about making your fuzzer find more things interesting. And we're going to do that by helping it crash. So imagine you have this nice buffer, and we're going to try to find an overread. Now, what's dangerous about an overread? What? Yeah, like your SSL private key. Heartbleed was an overread, and it was one of the more expensive vulnerabilities in history for who it affected, and it could leak your private keys. So, we're going to talk about how you might find that here. So, we have a buffer. It's sitting there. We know that there's going to be an overread. If you use sanitization, it's going to surround your buffers with poison bites, such that if anything touches them, your program will crash. Now, the trick to dealing with this is that if you fuzz with a sanitizer, you need to test with the sanitizer, because things like overreads will definitely crash with the sanitizer, but they don't always crash in production, because that red buffer will be missing. Make sense? Like, that's the one gotcha with the sanitizer. If you test with it and you're going to validate your crashes, you need to make sure it's still turned on so that you see them. Otherwise, you might get silent errors, which is the danger in something like an overread. It's not always destructive. Make sense? All right. And then I promised some people I would talk about... Come on. Mutational fuzzing is kind of the big paradigm right now, and this is the ones that developers encounter. And that cares about your inputs. You cannot mutate something if you don't have something to start with, and so improving your mutation is where you often sort of gain performance gains on something that's a mutational fuzzer. That includes libfuzzer, AFL, the basic implementation of VMF. So if nothing else, focus on improving your mutation for your target, and you'll get some big wins. Does that make sense? Like, this is easier said than done, but hopefully the idea rings true, right? Okay. Now, one of the things that's funny about mutational fuzzers versus generational is that you have to start from something. If there was no prior round of fuzzing, where do you get the seeds? You get them from the user because the program can't generate them. So that's kind of on you. So this was my initial research, so I'm going to get my little soapbox for a few minutes. But the initial corpus is that initial set of inputs that's provided by the user. Now, there are differing ideas about how much work you should put into it. The first one is what I call the conventional theory, which is that this thing is very important, and if you don't have one and don't put work into making a good one, you'll lose out. See libfuzzer documentation. This is a popular theory in academic, defensive, and offensive circles. Anyone guess who's missing from that list? Us! Yeah! Nope. All right, my computer's slow and it ruins my jokes. All right, there's a second theory. This is the author of the AFL fuzzer, who is himself a software developer. I mean, fuzzers are just software, we write them. And he put out this blog post where he basically conjured JPEGs from Hello World. Hello World is never a valid JPEG, right? You don't have to know much about file formats to know that. And the fuzzer, after 6 hours, was basically able to spit out valid JPEGs. And so this gave rise to, I don't have to do any effort here, I'll just run it, and it'll work out. This is something that's very popular in developer circles. But it is very different, than our friend over here that says this thing's very important. So, who's right, the developers or everybody else?
Yes.
Yes, all right. I love it when there's a trick question. Okay, they're both right, just not all the time. All right, so I have theories and data, but it's hardly airtight like anything else in fuzzing. And it could be a lot of things that give rise to the phenomena I will tell you about. Generally, the more structured the input, the more it seems to matter. When I was fuzzing SQLite 3 on a Hello World corpus, the server might have well been off for the whole damn week for all that it found. It found absolutely nothing. I could have shut this machine off and I would have had the same results. The same was not true about my sort of bigger binary blob, especially once you got past 24 hours. 24 to 74 hours, you really do sort of see about the same discovery behavior. And if you run it for a week, it's really, really obvious. But, it doesn't hurt to spend 30 minutes working on initial corpus. Nothing in my data set said you lost anything by spending 30 minutes to make an initial corpus, but you could gain a lot, especially if your data was structured. Also, we're developers. We have a test suite. We write the test suite, right? It shouldn't be that hard to just grab the damn test suite, shove it in the directory, and off you go. We have to do it anyway. If nothing else, you can run strings on a binary or a target, and you'll usually get enough to seed the thing. That takes 30 seconds. There really is an excuse for spending the 30 seconds. Everyone with me? All right. Now, but I'm sure you've all been waiting for, how do we shove this into our lives as developers? The first thing we have to do is talk about fuzzing limitations. Your fuzzy has to accept input. You can't fuzz a thing that doesn't take input. You also need it to take input quite frequently. If the genie says you have 3 wishes, you probably don't want to fuzz your wishes. Likewise, if you can only talk to a satellite every 20 minutes, you probably don't want to try something like fuzzing. You will get very old. So this is not always as easy as it sounds, although that sounds very obvious. Like, well, what kind of program doesn't take useful input? Well, there are actually a surprising number. It is hard on your machine. Fuzzing does really like to eat RAM, and it really loves your CPU. So it will take a fair amount of power and money if you're paying your own electricity bills. If you're using cloud infrastructure, fuzzing bills do add up. They tend to need beefy instances. Fundamentally, fuzzing relies on probability, and probability is not always your friend. What are the odds of guessing 1337 in an 8-byte integer?
Basically 0.
Yeah, basically 0. Someone says, 1 over 2 to the 64 is basically 0. You do occasionally get surprisingly lucky, but those sorts of things can hang up fuzzing. Things like in kernel state, like getting the kernel page table massaged just so, is a thing that probability is probably not going to be very helpful for either, right? It's also not good for truly dangerous code, because you must run it. If you're like, oh, no, we can't run it, like we think it's an implant, you're dead in the water on fuzzing. It does require dynamic analysis, which is to say, it needs to run. And more importantly, as developers, this is the area of my dissertation research, fuzzing does not know why. You often get a very bad signal-to-noise ratio. In fact, I'll show you what some developers in Linux kernels have had to say about that signal-to-noise ratio later. But understanding the results can be very expensive. Often it's harder to understand the results than through other forms of testing. Now, the offensive community doesn't care, right? They're just going to take it, plug it into their exploit chain. One of the people who does use this in his day job is like, look, I got 100 servers I got to own. I need to get in there, get my toolkit, get things running, get on with my day. I do not care what it is actually doing, which was deeply disheartening to me because I, of course, care a lot. And, fuzzing relies on approximations and assumptions. It's not mathematically, it's what we call mathematically unsound. So if you get an absence of evidence, your fuzzing job comes up clean. That doesn't mean your thing doesn't have bugs. It just means the fuzzer did not stomp on them this round. Or maybe it did and it just didn't detect it because whatever it is non-destructive. Make sense? Right, fuzzing is great, don't get me wrong, but no tool is perfect and every tool has limitations. And one of our most important jobs in software is to pick the right tool for the right job. Don't tell the Python community I said that. All right. So this is a thing that is a pain for us that is not necessarily a pain for the people who put fuzzing on the map, which is the problem of root cause. So as I mentioned, fuzzing can have a very bad signal-to-noise ratio, and some of that has to do with the assumptions it uses. So let me ask, if a fuzzer produced over 3,000 crashes, how many actual bugs do you think there are? Call out some numbers, come on.
100.
I got 100, all right.
Could be 1.
1, okay.
5.
By Price is Right rules, 5 is correct because it was 15. Now imagine you're the poor sod stuck with those 3,000 crashes and trying to find the 15 needles in that haystack. Are you going to like fuzzing much? No, but as I said, the people who do this for use it living are usually on the offensive side, and they don't care. They set up a script, they just feed them through, check that it crashes, and then plug it into the thing they need it for and get on with their day. So this is sort of pain that is special to us, right? And this is the problem I'm attempting to solve in my own research. But you should be aware that it exists, and that despite fuzzing being around for 130 years, this hasn't been a problem that has mattered until recently, because if you're an attacker, you don't care. Make sense? All right, so like all tools, there are no silver bullets and there are no free lunches. Your fuzzer does not replace your security team. It does not get you out of writing regular tests. It does not get you out of code review. It in no way replaces anything about good development or security best practices. You can't go, we have fuzzing, so we don't have to do these other things now. I understand that's the allure of automation, is you have to pay fewer people. That's not how this works. Okay. Make sense? All right. And because it can be expensive, please budget. It's going to take time. It's going to take money. And analyzing the results is probably the most expensive part of all. You're also going to need to fuzz a fair long. A lot of tests, people are like, I used to fuzz it for like an hour, right? Or they're like, hey, I want to put in my CD pipeline. 5 minutes max. And I was like, most fuzzers are not going to find gall in 5 minutes. And your attackers aren't running it for 5 minutes either. What most of them do is they take old hardware, they stick it in the back of their garage, and they go check it once a week to see if it spit out anything. Right? They are running it for weeks on end. Maybe you should run it for at least a week. Now, no resources are infinite. Testing for 3 weeks is a tough sell anywhere, but a week is probably fine. So you're probably not doing this on the nightly branch, and you're probably not doing it on each commit, especially in a large organization. But you might want to do it on like a release candidate. All right. Test-driven development. Design your code for testing. You are a developer. You need to design and test your ideas and your code. Yes, I know it's not fun, but I think we can all tell you from experience that retrofitting testing on top is a known migraine. Our field's been around for 50 some odd years. We know better by now, even if we don't like it. And I really, really hope the idea of designing your code for testing is not a controversial or a new one. If it is, wait until I have a beer in hand before telling me you think it's controversial. Deal? Cool. All right. And students, please be aware that we do test you on this in your whiteboard interviews. If we don't see you test your code before you write it and validate your algorithm, it is usually a quick trip to failing your interview. So if nothing else, you have a stake in this game because we do expect it of you. All right. I'm not always a huge fan of test-driven development, but does force you to think about how to know if your code's correct and how to get it to accept input. And guess what you need for fuzzing? You need it to accept input, and the more your fuzzer can know about your target and know if it's gone wrong, the better off it's going to be. So even if you're not doing this for fuzzing, if you do these things, your fuzzer's going to be in a better position. If your code's easy to test, it will be easier to fuzz. Make sense? Like, it's really just sort of things on top. And also, but for bonus points in design, if you can test chunks of your system individually, you can probably fuzz them individually, and you'll find more bugs, and you'll usually find them deeper. The thing I often see people do, particularly students, is they'll build an entire application, touch the bottom, and then they'll try to test it, and it doesn't work. If you can build it in sort of modular chunks, and you can test those modular chunks, you can fuzz those modular chunks. And you get better results, right? I think a lot of people think of fuzzing as a thing that developers have to suffer from later, but if you build your code well for testing, you'll get less pain from the fuzzer and better use of your time, which we're all a big fan of, right? Cool. Everyone loves fewer headaches. All right, kernel fuzzing is especially difficult. You have these deep state that you can't see. It's hard to observe stuff. And there's just way more things to lock down. As my OS professor was fond of saying, all code in the kernel is security code. Which is why it's very upsetting to me when I find people are landing stuff that breaks tests or refusing to put in tests in the first place. If you contribute to an open source software system, please put tests in, please run the tests. And remember that things that are non-destructive, such as leaking a kernel address, are actually rather difficult to fuzz for because they're non-destructive. Making a fuzzer that speaks those things is hard, but it is doable. And finding all the bugs, always harder than finding just one. One of the things we know from research is that different fuzzers will find different bugs with different probability on the same target. So if you are testing production software, you probably want to run more than one fuzzer. No silver bullet, no silver fuzzer. And also, the strangest question I got during the Linux Security Summit was someone asked me for a fuzzer to fuzz from the CPU up through their web app. That is not one fuzzer, that's a good 2 dozen. So you're going to need different fuzzers for different parts of your software stack. If you hopefully that also shouldn't be a controversial or strange idea. But it's shocking to some people. All right. TLDR, no free lunches, no silver bullets. You still have to do all the normal stuff you do to test your code. All the best practices still apply. You're going to have to budget resources for it. Please design your code for easier testing or fuzzing. If you remember nothing else from this talk, please remember to do that. It was my one takeaway lesson. And then you're going to need more than one fuzzer. You're going to need to fuzz for a while. And that harness is a thing I often see developers try to neglect. But this is our wheelhouse. It's writing code for one program to talk to another program. We should love that bit. This is our wheelhouse. This should be the fun part. All right. And then here's the lab. Thank you for listening. I hope I haven't kept you from lunch too long. All right, so we can take questions, or I can hang around. You can ask me questions. We can go to lunch and talk about things. Which would you guys like to do? It's a small crowd, so we can actually have this discussion about options. What's up?
Can you tell us really briefly what the lab is?
Okay, so you're going to find Heartbleed. So you're going to set up AFL on a Google GCP instance. You're going to install the fuzzer and you're going to run it. And then you're going to have the headache of, cool, I found this crash 5 ways. Which is actually the byte in here that is causing the overread. So this lab includes a run-through of the Heartbleed vulnerability, including the famous XKCD that goes with it, and a real-life chance where you have to find that magic byte that has the wrong number and discover that this is, in fact, not as easy as it sounds.
We have a question from Matrix. Hi, Hi, Allison. I'm also a PhD student conducting researching on fuzzing. Great presentation. I wanted to ask, what do you think about using fuzzing to test network protocols for the Internet of Things?
I think there have been several papers going after IoT. It was a hot topic like two years ago. And it's interesting because there's a web stack to go after, and there's also C code on the device. Now, the C code's way more interesting to me, but if you'd be more interested in the web stack. So,
There's a follow-up question, but if anyone else has questions in person.
Less of a question, more of a related statement. There's interest in hardware fuzzing, and it's the intersection of the IoT thing, but also people have found Intel processors and found instructions that aren't supposed to exist.
yep. So the comment, more of a comment really, was that hardware fuzzing is also an active area. Now, it's a place I have no experience, so I know it exists, but the visitor mentioned that we have fuzzed CPUs and found instructions that aren't supposed to exist. And this is particularly fun because Intel is widely known not to have published all of their instructions. You were supposed to pay for a special book, so this one was extra egg on the face for Intel.
Follow-up from Matrix from the same person. If a fuzzer finds no bugs, then can we use code coverage to measure its effectiveness?
That depends on who you ask. Not everyone agrees that even if you have code coverage, does it mean that the fuzzer was effective in those areas? So, for example, in my runs on Magma, I stomped on one of the vulnerabilities 100,000 times. So I got code coverage through that spot 100,000 times, and I didn't trigger the bug at all. So I'm of the opinion that just because the fuzzer covered an area doesn't vouch for it, because we know that the fuzzers often stomp on code points without triggering bugs. And this is triply true for your non-destructive ones, like overraids, password leaks, heap leaks. Type confusion is one I'd like to go after.
Any other questions?
And no, there's my email. So if you want to talk to me about research stuff, feel free to email me. I don't really use LinkedIn or Twitter or X or other social media. I find it kind of exhausting. But the talk will be up on my GitHub. So, please talk to me. I'm here to talk to people. All right, I think with that, everyone wants to go to lunch, right? Yeah, I do too. All right, thanks, guys. Break down.
Awesome talk.
Thank you.
That was fun night last night?
Oh, so much failed.
Yep. Well.
start streaming and start recording. All right. You were live. These microphones right here are your microphones.
Okay, so stick around here.
Yes.
All right.
Thank you so much.
Okay. Man, AV people are just like a godsend in general, for conferences, hardest working people. What's that?
Does the microphone on the podium not work yet?
I don't know.
Well, I was thinking of the one on the...
Yeah.
I guess not.
I guess not. This is for the live streams. I can try to turn this on.
It doesn't matter, I guess. Maybe I don't know.
Is this on? Okay. Hello? Hello. Pop, pop, pop. Fizz, fizz, fizz. All right, ladies and gentlemen, we're just going to project. All right. So thank you, everyone, for finishing through. I believe it's past time. So thank you for everyone for finishing through your lunch quickly, running back, and coming to my talk. So my name is Kyle Rankin. I have been building secure Linux infrastructure for almost 25 years now. I've done a lot of technical writing. I was a columnist for Linux Journal magazine for a number of years. I've published a number of different books on technology. Most recently is one about, it's very meta, it's about how to write a tech book. So if you want to read a book about how to write a book, then I actually have a couple copies up there you can check out. Most recently and most relevant to this talk, I worked at a company called Purism, who, as chief security officer and then later president, where we made hardware that ran open source software. And that's a lot of the experiences in this talk are based on that experience. All right, so bit of a semi-introduction to semi-firm firmware. So first, I want to just get out of the way that I am not a firmware expert. So if there is a firmware expert in the audience, let me go ahead and concede that point to you. There's no need after the talk or during the Q&A to make it clear that you know more than me about firmware. I go ahead and concede that to you. At best, I'm sort of a semi-developer for firmware. So by that I mean I have developed some software called Heads, which is a payload that runs on top of Core Boot. I'm a contributor to that project, and so I've done work in that realm. But the good news is this isn't a technical talk, so it doesn't really matter that I'm not a firmware expert because this is a policy talk. So what we're going to be talking about instead is firmware policy, not necessarily how firmware works. Now, that said, I did make hardware that ran free software and open firmware, so I do have a background in doing that, and that's going to be what's informing what I'm talking about today. The thing to know about this is that it's really challenging to make all firmware free, and you'll see why as we get into the talk. But the thing is, open hardware, and all of us probably in this room have some interest in seeing more open hardware out there. Open hardware depends upon having free firmware. But the problem, and this is what the crux of this talk is that current policy, if you wanted to follow some sort of guideline or policy for making open hardware, the current open hardware policies with respect to how they talk about firmware are out of date and are based on a world of firmware from a couple of decades ago. So in this talk, I'm going to start by explaining what is firmware, defining firmware. Then I'm going to explain why firmware isn't firm. Also, why firmware isn't usually free. Then we're going to talk about the Respect Your Freedom certification, which is basically the only standards document that exists right now that helps guide someone who wants to create freedom-respecting firmware. We're going to talk about the Respect Your Freedom's exceptions that they have for proprietary software. They do allow proprietary software in the Respect Your Freedom certification. We're going to talk about what those are. Then we will talk about two different experiences attempting to make a modern Respect Your Freedom compliant device. And then finally, based on those experiences, talk about some recommendations for policy improvements. So, what is firmware? Well, first, let's define a couple of other words that informed this. So first, what's hardware? So hardware, we're talking about physical chips, electronics, tangible things you can touch. That's all hardware. Software, in a high level, instructions that a CPU executes. And so where's firmware? It's actually sort of a play on words. People who first used this term were trying to think about what do we do to describe this, these instructions for something that sits sort of between the hardware and software. And so they said, well, it's not exactly hard, it's not exactly soft, it's kind of firm. We're going to call it firmware. Traditionally, when we talk about firmware, we're talking about instructions that are flashed onto chips on some piece of hardware. Originally, these were write once and read only afterwards. Once you flashed firmware on a chip, generally speaking, if you wanted to replace it, and at least originally, you had to replace the chip, put a different chip on. Firmware provides this interface between the operating system and using drivers. So drivers will communicate with firmware, and it provides an interface between that and the hardware that it is running on. So some examples of firmware that are on computers you use right now would be a BIOS, video cards, network cards, sound cards, even hard drives have firmware running on them that are separate from your operating system. The thing is, firmware isn't actually firm. It's more like tofu, and it comes in a couple of varieties. So you have some firm varieties, but you also have semi-firm and even soft. You can make a very strong argument, and many people that are firmware developers make a strong argument that firmware is just software in the modern day. There is really no such thing as firmware. So these are not official definitions. These are Kyle's definitions, just so that we have some sort of means of talking about this stuff. So to me, when I'm thinking of what modern firmware is firm, I'm thinking of something that is write once and then read only afterwards. So something that you're burning onto a chip, and once you burn it onto that chip, you can't replace it. So I consider that qualifies as firmware. To me, semi-firmware is something that is field upgradable, but to be field upgradable, you need some sort of a hardware flasher. You need specialized tools, something like a Pomona clip or something that you would clip onto the chip and then write new instructions onto it, overwrite the previous instructions and write new firmware onto it, but using some hardware device. Soft firmware or software I would qualify as firmware that is OS upgradable with a software flasher. So there's a lot of examples of this where you don't have to leave the comforts of your operating system. You can reflash firmware from within it. And that's really, in my mind, is soft firmware or just software. The other thing that's important to note, and this is going to come up later when we talk about Respect Your Freedom certification, is that a lot of firmware isn't just something that's burnt onto a chip and never changes. There's also often runtime instructions and configs that get loaded at initialization time. So when the hardware is brought up, there's some sort of base level of code that bootstraps the hardware and then reads the full firmware from some other location, maybe a ROM on the hardware or maybe from somewhere else. In addition, sometimes even the operating system will provide initialization time instructions and config when you bring up the hardware. There's a lot of examples of this, wireless cards being the best example, which we'll talk about in a little bit later, does this. Even your CPU gets firmware updates, gets what are called microcode updates, where even something that you would think would be just sort of like standalone, when you power on your computer, there are a couple different mechanisms where either the OS or your BIOS or UEFI boot firmware can load CPU microcode to overwrite what's actually been burned onto the CPU. One sort of semi-distinction from software, if you're going to say, well, if you're saying firmware is basically software, there's one major distinction, which is which chip is executing the code. Generally speaking, software is being executed by the CPU, and firmware is being executed by some chip that's not the CPU, something generally speaking that's on some hardware. So if we're saying firmware isn't firm, why isn't it firm? Why did we move from somewhere? Is there some sort of nefarious plot to sort of promote proprietary software or something? Is that why firmware used to be burned on the chip and now it's more soft, it's not firm anymore? Not really. It turns out that firmware, like all software, has bugs. And traditionally, if you had, when you're releasing firmware, you had to be very cautious about writing that. Is very similar to designing hardware, where there is a notion that it has to be production ready. There's no changes after the fact. But obviously there's problems with that. Firmware has bugs, and so these days, pretty much every hardware, all the hardware that we have that uses firmware has some mechanism to update that firmware to fix bugs in the firmware itself. And we use that, all of us with computers, whether you even know it or not, will often have firmware updates applied to your OS or to your hardware. Not only does it allow bug fixes, but often there's new features. There's features that a lot of hardware is being developed a lot like software is now, where you will release some sort of initial version of it, knowing that there's future features that you will add later, but you didn't have time to finish before the release. And so you'll have some sort of initial stab at having hardware out there, knowing that you can then unlock extra features or optimizations later with a firmware update. The other thing is hardware actually has bugs too. As much as hardware designers tried their best, because it's really difficult to fix something that you've soldered onto a board, hardware has bugs as well, and firmware is a really good mechanism to fix hardware in the field. Often it's one of the primary approaches that people will take to fix a hardware bug that gets discovered after hardware's been shipped. For example, that's how Intel responded to the Meltdown Spectre bug. It's a security bug without getting into that's a whole talk of its own. But essentially, there was a bug that allowed the discovery of secrets that were loaded into CPU cache, if you knew how to ask nicely. So, but this was an actual bug in the CPU firmware. So Intel fixed that with microcode updates, and actually has continued to address aspects of this with fresh microcode updates. Every 6 months or a year or so, you will see a new microcode update that seems to patch some newly found version of this bug. The other thing, especially from a free software standpoint, is if your firmware isn't firm, if it's something that is field upgradable, it also could be potentially replaced in the future by open source firmware, which is a good thing. And in fact, that's something that at Purism does that. Like the boards that you would typically get all sort of default to having non-free boot firmware on them. And if they were read-only, then there would be no option to replace them with something that's not proprietary. But because they're field upgradable, then Purism was able to replace them with, in the case of a BIOS, core boot after the fact. This also allowed them to ship laptops initially that did not have core boot on them, with the promise that it's being worked on, and then later customers were able to then upgrade into a open source boot firmware, even though they started with a proprietary one. So the thing is, firmware is usually proprietary. Almost all firmware is, most. Let's just say most. I feel comfortable saying that. The thing is that it's more hidden than software. Your average person doesn't interact with firmware on a daily basis, and so there's not a lot of thought given to it. It has much less of a focus in the free and open source software community than proprietary software does. But that said, the pain of proprietary firmware is mostly felt in the free software world. In the proprietary world, the proprietary OS or boot firmware or whatever just sort of handles it for you. There's usually tools that come from your vendor that allow you to update firmware, that will automatically apply updates. And if there's any bugs, usually you feel these bugs or quirks when you're booting Linux on a system, and you have to have some sort of free driver that's interacting with this proprietary firmware. But that said, there's been a focus on free firmware that's much greater now than it was, even 5 years ago and definitely 10 years ago. There's a renewed focus on it for a couple of reasons. One, we now have the option to have 100% free software OS. So there's a couple of projects out there where you can get a complete distribution of Linux where 100% of the software is free software. Well, now imagine that you have that. You've climbed that mountain. Now you're up there, and you're going to look around and say, okay, well, my OS is 100% free. What's next? Is there anything left on my computer that's not free? And it turns out the next thing you would look for is your firmware. And it turns out there's a lot of firmware on your computer that's not free. The other reason is that there's a renewed interest in open hardware. There's a lot of buzz about RISC-V, for instance. A lot of the interest in RISC-V is because of the promise of having a new CPU architecture that is completely open, that also has the option to have completely open firmware, and there's a lot of excitement about that. There's also a growing concern about firmware-based attacks. There have traditionally always been some attacks that have targeted firmware, in particular for persistence, because the nice thing about attacking firmware is that if someone rewrites their OS in response to noticing that they've been hacked, you can put an implant in firmware that reinstantiates your access to the machine. And there's been proof of concepts in the wild and actual attacks in the wild that do this. And so that and the fact that there has been a growing number of exploits like that has caused firmware to get a lot of attention, in particular proprietary firmware, because it's more challenging to inspect it for these kinds of either intentional backdoors, accidental backdoors, basically think like developer mode kind of left, or debug mode accidentally left on and shipped in a production product. Things like that have happened a number of times. Or something actually intentionally bad. With this proprietary, you can't audit that to see whether there's something like that in there. So people who are concerned about that sort of thing are also very interested in the option to have free firmware on their devices. So some recent examples of wins for the free software community for firmware would be Coreboot, which is an open source project that replaces your boot firmware with something that's open source. It does, in most cases, have blobs, but the core of it is open source. And then there's also a couple of projects to replace the embedded controller, which is another a chip on your computer that's critical for booting. It does a lot of growingly more and more important things on your computer, such as managing your keyboard and input devices. It does a lot of other hardware initialization now. There are a couple of projects. Purism System 76 and Google also have open source embedded controller firmware that they've released for hardware. Even then, even with those examples, there are still blobs, and by blobs I mean some sort of binary proprietary blob that can't really be inspected easily. Which leads us to Respect Your Freedom certification. So this is, when I say Respect Your Freedom or RYF, this is the Free Software Foundation certification for open hardware. They released a standards document that said, this is our standard for if you want to create freedom-respecting hardware, build it in this way, and you can get ours and apply for certification, and you can get our stamp of approval that this meets our standards for respecting your freedom. Currently, it's one of the few criteria, the few policies you can look at that actually talk about free software and firmware that I found. When we were at Purism looking to create hardware that could pass this certification, and then even afterwards, looking at it, this is one of the few documents that spells out some sort of policy, some sort of standard for behavior that passes, that has some third party that cares about free software stamp of approval on it. If, like, for example, Purism could have created their own and said, yeah, we have a policy and we stamp it and we approve ourselves, but that doesn't really make any sense, right? You need some sort of third party that sets the standards. This program's been around for quite a few years now, and you can go to their site and see a list of hardware that has been certified Respect Your Freedom. For the most part, most of the certified products are network adapters. In addition, there are also a couple of older model ThinkPads. There's even 3D printers if you were to go through the hardware list. But for the most part, what you'll notice, the trend you'll notice is it's generally speaking older hardware, and the reason for that is because of how modern firmware is implemented on hardware, is implemented in a way that violates some aspect of Respect Your Freedom. So here's a couple of like high-level bullet points for the certification. Number one, it requires that all the product software that comes with the hardware be free software. So that means if you have a network adapter that you ship and it comes with, well, in the olden days, either a floppy or a CD, nowadays with some sort of, I guess, documentation or link for drivers, where you can download drivers, and those are proprietary, you will fail this step of Respect Your Freedom. They expect all software that comes with the device to be free software. Also, you can't steer the user toward non-free software. So that example would be, okay, it comes with free software, but in the box there's instructions that say, okay, this barely works. If you really want it to work well and have full features, go download this proprietary driver. If you do something like that, that would violate this policy. The thing that might be surprising is Respect Your Freedom actually does allow some proprietary firmware, and they spell out some exceptions that allow you to do it. So let's talk about that. So here's the main firmware exception. I'll just go ahead and read it aloud. However, there is one exception for secondary embedded processors. The exception applies to software delivered inside auxiliary and low-level processors and FPGAs, within which software installation is not intended after the user obtains the product. This can include, for instance, microcode inside of a processor, firmware built into an I/O device, or the gate pattern of an FPGA. The software in such secondary processors does not count as product software. So, to summarize, if you have proprietary software on hardware, but it's basically burned onto, even if it's replaceable maybe later, but if the user doesn't have to do anything after they receive the hardware to use the hardware, then that's considered basically like the equivalent of a circuit to the Free Software Foundation. So they have a very big exception for this. So proprietary firmware is allowed in that case. However, there is an exception to the exception. And specifically, the exception is about the BIOS. And so this carve-out says the BIOS of a PC runs on the CPU, not on a separate secondary processor. So this exception does not apply to the BIOS. So the essential distinction that they're making here is whether the CPU is the one that's running the firmware or whether the secondary processor runs firmware. And the reason they do this carve-out the other distinction is whether the user must install some sort of software after the fact. Those are the two main distinctions about whether or not proprietary firmware is allowed. So this rule in particular, this exception rules out basically all modern Intel platforms that require the Intel management engine to boot, which is pretty much everything after ThinkPad X200 era. Everything before that, there's options. Everything sort of after the ThinkPad X200 series, including the X200, although some people have found a workaround for that product. But everything from that point on is a modern enough Intel platform that it requires the Intel management engine to boot and function, and there's without any workarounds that anyone's aware of. And also, it rules out a lot of modern peripherals. Most modern peripherals, modern hardware that you would add to a computer has something that would violate this exception. So, with that in mind, how would you go about making a modern, if we acknowledge that a lot of the Respect Your Freedoms devices that were certified are relatively older hardware, what would it take to make a new one? So, one, it's difficult. It's very difficult. I can't stress how difficult it is. That said, the software side's relatively easy. We have, like I said, options for 100% free OS. So, and there's still quite a few options for free software drivers in general for hardware. And so, with all of that combined, that part's not too difficult if you can control the hardware, which you can if you're designing something. The firmware is really the hardest part of this process. And so, I'm going to explain why with two real-life examples. The first one is the Librem 14 laptop, and the second is the Librem 5 phone. So, let's do a quick overview of the Librem 14 laptop. This is a reference 10th gen Intel laptop. It has video, Ethernet, and Wi-Fi cards that all use free software drivers. It runs 100% free software Linux distribution, in this case Pure OS. It has a core boot BIOS. It has a free software Librem EC embedded controller firmware on it. But it still doesn't qualify for Respect Your Freedom. Okay, so even with all of those check marks checked, it still doesn't qualify. Well, why doesn't it qualify? There's blobs. So what are the blobs? The following core boot blobs disqualify it. So first, there's the Intel FSP. So what this does is initializes the RAM, PCIe, SATA, and some other devices on the machine. The Intel management engine itself, we've already talked about that. That also disqualifies it. Possibly the fact that it has CPU microcode in it might disqualify it. The Intel CPU microcode to patch the CPU for Spectre and Meltdown, among other things, is in the core boot firmware. And we'll talk about the probably later because it's questionable. It's not well defined. And then in the future, also what Purism coined as the Wi-Fi blob jail. So what is that and why does that exist? Blob jail. All right. So at the launch of the Librem 14, I mentioned that the Wi-Fi card had 100% free drivers. That's But the thing is there's only a single Wi-Fi card on the market you can buy that you can run with 100% free software drivers, and that's the Atheros series of Wi-Fi cards. It's the only blob-free option. The problem with that card is, one, it has older Wi-Fi specs, so it doesn't support the latest and greatest 802.11, like, etc., alphabet soup standards. It supports some of the older Wi-Fi standards, so you're not getting maximum speeds and that sort of thing. They're also getting harder to find. This is really important because at one point they're very easy to get. Now it's pretty tricky, and it's getting harder and harder to find new ones for the market. So that's concerning to a company selling hardware, right? The Wi-Fi is patent encumbered, so that means if you wanted to make a brand new card, it would be very challenging to do that. It'd be very expensive to make it, and you'd also have to deal with a lot of Wi-Fi patents that the industry holds. And so that's not really an option. So the backup plan is to take an Intel Wi-Fi card and then put all of the blobs. There's some blobs that the Intel Wi-Fi card needs to initialize. Instead of putting them on the OS where the user might see them, you put them in a blob jail, which is something in the boot firmware. What happens is the boot firmware will validate the blob, so basically make sure it hasn't been tampered with, and then it passes that to the kernel at boot time. By doing it that way, the operating system can be 100% free software. The user actually doesn't even know it's happening, but the Wi-Fi card will initialize because it's being passed this firmware when it turns on. And again, it's also important to note the CPU in this case doesn't actually execute the blob. What it's doing is simply copying the file to hardware. It's not running anything. And that, to me, is an important distinction. It's not actually executing code, it's copying a file.
Does that qualify for ROIF?
Unclear. We're not sure whether that qualifies. Possibly. But the Librem 14 is disqualified for 5 other reasons. So, but yeah.
That'd be a cool processor, right? Running not CPU code, right?
Yeah, the question is this hasn't been tested by, or the Free Software Foundation hasn't made a stance on copying a file, the CPU copying a file to hardware versus, but I suspect in a way that the user didn't see and what the OS didn't touch. That's the workaround, right? So Librem 5 is a in-house ARM-based Linux smartphone that was made from scratch to comply with the ROIF. This was the design document that everything was built around to try to comply with the standard. It runs the same OS as the laptop, so free software all the way there. The modem and the Wi-Fi and Bluetooth cards are on removable M.2 cards, so you can actually remove those things from the device if you want. The hardware was chosen in general for optimum free software support to make sure that we had the best chance of getting, not only just having drivers work out of the box, but also upstreaming all the hardware support we needed into the mainline kernel. It took a lot of kernel work to get in a modern ARM CPU to work, which is why a lot of Android devices, they'll like lock it in with one big proprietary blob driver that gets that hardware working on one version of the kernel and sort of is locked in place. And in this case, the goal was to mainline everything into the mainline kernel so that it would be indefinitely supported. It has blobs. Some of the firmware blobs are actually free software blobs that are copied over. They're not proprietary, but there are some closed blobs too. But they were designed in a way to comply with the ROIF. And so here's what happened. So here's a couple of the blobs. First, the touchscreen and the wireless WAN, so like the modem, they both have soft firmware. By that I mean it has firmware, but you can update it from within the OS using OS-based tools. There's no initialization blob though. You just once they're burned on, there's nothing at power on time that has to be copied to these pieces of hardware. But everything else that uses firmware has to have runtime loading of the firmware. So all of these, though, to make this compliant, they load blobs from ROM storage that's outside of the CPU. So there's a ROM storage in the hardware that these things reside in that then get copied to the hardware when it's initialized. So some examples of the USB-C chip, DDR training, so the RAM training, and the DisplayPort all require this type of firmware. Originally, there was this Red Pine Wi-Fi card that did not require initialization, but it was deprecated in favor of a SparkLAN Wi-Fi card. That does need a blob jail. None of these taint the user, though. So how will we improve firmware policy? First, we need a policy that reflects the current state of hardware, not hardware like it was like 20 years ago. So the current policy is, let's say I have something that's not a CPU that copies a blob from ROM. That's okay. What about if the CPU copies a blob from the flash storage? Maybe that's fine. But what if it does the same thing, but the file's on disk? That's probably not okay, but we're not sure. If it executes the blob from the disk, that's definitely not okay. We know that for sure. So for the Librem 5, there's all these ROM copy hoops that had to happen to comply with the standard. But that means when you're designing hardware, you have to add extra chips just to do that. You have to have special firmware that handles that. And you have to flash the software you still have to flash software to update. It's really a distinction without a difference. Whether you're having to do these hoops to comply with the letter of the law, but the distinction's very, there's not a big difference between them. You're just hiding things from the user. The fact of the matter is, there's many good reasons why the practice of having some sort of blob be passed to hardware at initialization time, that's not going to change. There's a lot of good reasons in terms of maintainability, patching security flaws, all kinds of other things. That's the reason that this is common practice now, and that's not going to change. So what we need is an exception to this rule when a blob is not executed, but merely copied. So there's a file in some location, and either the OS or the CPU or something makes a copy of that file and passes it to the hardware so it can be initialized. We also need an exception specifically for CPU security microcode updates. I think that the fact that the CPU is running proprietary firmware, regardless, and it's not, I don't think that the benefit of freedom at the expense of security is great in this case. I think there should be an exception carved out specifically for microcode updates for the CPU. And ideally, there would be sliding scales. As someone who's trying to do the right thing, what you want to do is encourage steps along the way to get freer and freer with every step. Right now, there's a binary: you either comply or you don't comply, which means if you made a really honest effort and did the best that you could, but you're only 95% of the way there, you're still rated as equivalent to someone that has 100% proprietary software on their hardware, proprietary firmware, which it would be more encouraging to the community and people who are trying to do the right thing if there was some sort of sliding scale of increasing compliance, so you get some sort of pat on the back or recognition for making an effort. And when someone's comparing two pieces of hardware, they can say, okay, well, this one is, say, level 3 compliant, but this one's only level 1. Maybe I will go with the level 3 compliant because it respects my freedom more, or whatever. So in conclusion, now we have options where all of the software on your system can be free. So as a result, the firmware is in the spotlight. Firmware is not firm. We've established that. It's more like tofu. Soft firmware, though, the benefit of it is that it allows you to replace proprietary firmware down the road with open firmware. You have the option now to write a replacement and use it that's open source, and that's great. There's also many people trying to do the right thing here, but they're limited by policy right now. And so hardware's hard, open hardware's even harder, and people who are trying to do this work need updated policy guidance. And ideally some kind of guidance that allows incremental process toward being 100% free. Thank you. I think I'm running right at the edge of the talk, so what I will do is take Q&A outside. Thank you so much for coming to my talk.
Great, if you're willing to get the link out, we'd love to hear it.
I got started in open.
Okay then. I don't think we were recording.
I don't know when I
Test. That's okay. Or maybe it was being done here. I don't know.
everyone. Knuth's literate programming idea was that computer programs could be expressed in a natural language and be human-readable documents rather than written exclusively for machines to